Question 7, Part B. The velocity of a particle is given by v equals 2 minus 4 cos t for t greater than or equal to 0 and less than or equal to 2 pi, where v is measured in meters per second and t is measured in seconds. Part 1. At what times during this period is the particle at rest? The particle is at rest when the velocity of the particle is 0. In other words, 2 minus 4 cos t equals 0. Rearranging this equation to make 4 cos t the subject, we get 4 cos t is equal to 2. Dividing both sides of the equation by 4, we get cos t is equal to 1 over 2. Then taking the inverse cos of both sides to isolate t, we get t is equal to inverse cos of 1 over 2. Now we can treat t as an angle. 1 over 2 is a ratio. Now it's a positive ratio, which means t is an angle in either quadrant 1 or quadrant 4. So t is equal to pi over 3, which is a quadrant 1 angle, or 5 pi over 3, which is a quadrant 4 angle. But t also represents time. Therefore, the particle is at rest at time t equals pi over 3 seconds and time t equals 5 pi over 3 seconds. Part 2. What is the maximum velocity of the particle during this period? Consider the behaviour of cos t in the velocity equation v equals 2 minus 4 times cos t. Now, cos t will vary between -1 and +1. Hence, 4 times cos t will vary between -4 and +4. So the minimum velocity is given by 2 minus 4, which equals -2 meters per second, and the maximum velocity is given by 2 minus -4, which equals 6 meters per second. Therefore, the maximum velocity of the particle is 6 meters per second. Part 3. Sketch the graph of v as a function of t for t greater than or equal to 0 and less than or equal to 2 pi. Consider the transformations on the graph of the base curve v equals cos t to become v equals 2 minus 4 cos t or v equals -4 cos t plus 2. It's important to know what the graph of the base curve looks like to begin with. What we're going to do is to multiply cos t by -4 first. And what that does is to dilate or stretch the graph of cos t vertically by a factor of 4 and then reflect the graph in the x-axis. In other words, flip it upside down. Then we're going to add 2 to -4 cos t. And what that does is to translate or shift the graph of -4 cos t vertically up by 2 units. And here is the end result of all those transformations. Here is the graph of v equals 2 minus 4 cos t. Notice where the minimum velocities occur at t equals 0 and t equals 2 pi, and the minimum velocity is -2 meters per second. Notice the line of center at v equals 2. Notice also where the maximum velocity occurs. It occurs when t is equal to pi seconds, and the maximum velocity is 6 meters per second. Part 4. Calculate the total distance travelled by the particle between t equals 0 and t equals pi. Since the question is asking for the total distance travelled by the particle rather than the displacement of the particle, we need to consider the unsigned area bounded by the curve v equals 2 minus 4 cos t from t equals 0 to t equals pi. If you recall from part 1, we found that the particle is at rest at time t equals pi over 3 seconds. Between t equals 0 and t equals pi over 3, the velocity is negative, which means the particle is travelling backwards. And between t equals pi over 3 and t equals pi, the velocity is positive, which means the particle is travelling forwards. Now the sum of these two areas will give us the total distance travelled. Now we know that the area is going to be negative from t equals 0 to t equals pi over 3. So when we're performing the integration, we need to use the absolute value function to convert this negative area into a positive area, and then we add it to this positive area, and then we'll get the total distance travelled. So we'll need to split the integral up into two separate integrals, one between 0 and pi over 3, and the other one between pi over 3 and pi. So the velocity of the particle is 0 at time t equals pi over 3. The velocity is negative for t between 0 and pi over 3, and positive for t between pi over 3 and pi. Hence, the total distance travelled is given by the absolute value of the integral of 2 minus 4 cos t dt from t equals 0 to t equals pi over 3, plus the integral of 2 minus 4 cos t dt from t equals pi over 3 to t equals pi. Performing the integration, we get the absolute value of 2t minus 4 sine t from t equals 0 to t equals pi over 3, plus 2t minus 4 sine t from t equals pi over 3 to pi. Applying the limits of integration, we get the absolute value of 2 pi over 3 minus 4 sine pi over 3 minus 0, plus 2 pi minus 4 sine pi, in brackets, minus 2 pi over 3 minus 4 sine pi over 3, in brackets. Now, 4 sine pi over 3 is an exact ratio. That gives us negative 2 root 3. So inside the absolute value, brackets, we have 2 pi over 3 minus 2 root 3 plus 2 pi minus 0, since 4 sine pi is equal to 0, minus 2 pi over 3 minus 2 root 3. Now, expanding the brackets here, so in other words, this negative gets multiplied through to the terms inside the bracket. Also noting that 2 pi over 3 minus 2 root 3 inside the absolute value brackets, inside that, that's negative. So if we then remove the absolute value brackets, we need to switch these two terms around to make it positive. So removing the absolute value brackets, switching these two terms around, expanding the brackets here, we get 2 root 3 minus 2 pi over 3 plus 2 pi minus 2 pi over 3 plus 2 root 3. Combining the like terms, that gives us 4 root 3 plus 2 pi over 3 meters.